All right, I'm going to start recording now. For those of you that are coming in, here's a couple warm-up problems. Then I got another problem that's fun that we'll do. That'll give you some practice on stuff we've done, a lot of stuff we've been doing lately. So enjoy. Tell me, we'll do these together in a little while, but tell me what you get before we do. I know some of you have been working on for 10 minutes, so let's give the people that walked in late a chance. Anyone enter recently, Brandon?
Yeah, we've gotten a few. I just counted and we have 16 right now.
Hey, Brandon, the symbol right next to the W vector, that's perfectly.
Where?
Which W vector? Oh, the N. Oh, that's N. Okay.
Oh, you know, that's an answer.
Okay. Oh, that's perfect. I thought it was like perpendicular.
Yeah. That's
All right, so let's take a look. What do we got to do to find the volume of the parallel pipette? What's the operation?
Cross product, I'm hearing.
Would it be the dot product of U times the cross product of D times W?
Did you hear that?
No, I didn't.
Using the dot product with U times V with, say it again, sorry?
So it would be like the cross product of D times W, and then you take the dot product of that result with relation to W. I mean,
So you said the cross product of U and V, you said? U and V and then dot product with W?
We can do that. I like that. Let's do that. That sounds fantastic. All right, not magnitude. I need it regular,
Yeah.
but it should be positive. So single value, absolute value. Let's do that. All right, so we'll do the left one here. So U cross V. So I can do the 2x2 matrix. This is how I did it in the video. You'll grow past this because this just takes up more time writing it. Then you start doing the 2x2 matrices pretty quick. But until you do, maybe I should show it a little bit better. J has 3 and 2, 4 and 1. And then we got plus K hat. And that's 3, 1, 4, 5. So here we've got 1 minus 10 I hat, 3 minus 8 J hat, 15 minus 4 K hat. So U cross V is, I guess I don't need absolute values. Absolute values at the end. -9. 3 minus 8 is -5, and then we make it positive with the other negative. 11. And now we want to dot that with W. And that's 1, 2, 4. -9 times 1 plus 5 times 2 plus 11 times 4. I got -9 plus 10 plus 44. 1 plus 44 is 45. 45 cubic units.
And that could work too if you did like cross product of V and W and then the dot product of U.
You should get the same thing.
Yeah.
Yeah, because it's the law of, there's a word for it. I don't know off the top of my head. There's a law that states that you can do it in any order and it'll still equal the same thing. I don't remember what it was called.
Or you can think about it geometrically.
Was
I
it
mean,
commutative? I think so. Maybe.
if we're going here and we got a vector here, a vector here, a vector here, it doesn't matter which two we cross. If we dot with the third one, we're doing the same operation.
Yeah.
So let's take a look at that other one. We'll do the same thing. U dot V or U cross V. We got 4, -8, 1, 2, 1, 2, -2. And now skipping doing the, you guys want me to do write the 2x2 matrices?
I think you're good doing it this way now. It's good to have the 2x2. It's just good for just kind of understanding what's going on. But I know it's a lot of work.
It
Can be a
just
lot of
slows
work.
it slows a lot of things down, even when you're like when you're on a test.
Yeah.
The problem is you can make it's you're more error prone, so you have
Oh, yeah.
to make sure you're paying attention.
Yeah, it's fine
negative
to
8
skip
times
steps. It's fine to skip steps as long as you don't make the mistakes that come along with them.
So I'm getting 15, negative 10, positive 10, and 20. So that's U cross V. And now we'll dot that with W. Three, negative 4, 12 was W. I've got 15 times 3 is 45. 10 times negative 4 is negative 40. And 20 times 12 is 360. Not 360. What am I doing? 240. 240.
Yeah. Yeah, sounds about right.
So 245. Units cubed. Let me give you one more. Let's go with 5, negative 2, 1. 4, negative 1, 1. 1, negative 1, 0.
Yes, I got a question.
So if you switch two rows and then determine it makes it negative. You can't do everything to absolute value. If it's negative.
So I've got a question asking, because when you switch when you have a cross product and you switch, say, V and U, it'll turn into a negative answer. Do you have to find the absolute value of that answer before dotting the product?
No. It should, because whatever we're getting, effectively, if you do U cross V, what you're doing is you're basically doing this corner up here. If this is U and this is V, if I go U cross V and it's going inward like that, we're dotting with that. Or if we come up here, this is U and V and we're crossing this way, it's still getting dotted with that vector. So the outcome, you might get a negative outcome when you're done, but you don't want to go through and like, let's see, up here we had a negative for U cross V. I don't want to make that negative 9 a positive 9. We'll just make the outcome positive at the end if we get a negative outcome. Or since you'll have the negative, if you change the order of them, like if you switch the rows and you want to put the negative out front, you can just multiply the negative back through at the end before you dot. Either way.
But that could just cause us a whole slew of mistakes if you kind of forget to
Right.
put
I
negative in one
hate,
spot.
yeah. It's going to give a lot of mistakes. I hate recommending that or suggesting that, but
It may be a pessimistic thought process, but it's a safe thought process. The more steps you do in a math problem, the more likely you are to make a mistake. That's for sure. Yeah, that's why I like to keep my answers in the most unsimplified form I can.
So that unit cube is have to or
Oh, showing that it's a units cube. What do you think? Do you want your students to show that it's units cubed when calculating for volume
When
or
it's
area?
it's good practice. It indicates it's a volume, not just a number.
But they're asking if you're going to dock points for it on the like a test or something.
I might
think that's
deduct
what-
half a point.
have to.
How you doing this morning, Professor Jones?
I'm doing pretty good. How are you?
Good here, doing good, made it on time, so it's a good day. Job good.
That is always a good day.
Sure.
All right, I've got one person, I've already got a message about Sunday for Starbucks. So I'll definitely be there Sunday. If someone messages me about Saturday, I'll be there Saturday too.
At what times?
8 to 10 a.m. I'm not going to a coffee shop at night. That'd be lame. Did I not make an announcement about that? I thought I did.
You might have.
I did not. I'll have to make one. So I'm assuming you guys done it. Let's do you cross. You know what? I'm going to do U cross W.
I have no idea if I got some extra.
Oh, okay, first one, so you're just. I just write.
Yeah.
Did you guys get that? Did you guys get 0? Is anybody responding?
I see, I saw a couple nods.
What does getting 0 mean?
Orthogonal.
That it's orthogonal, if I can speak correctly.
What's orthogonal?
Like two of them are in the same line.
It would probably be the one that the U cross V and the W, that would be orthogonal to each other, right?
Aren't they orthogonal to each other?
So we've got U cross V. I did V cross W. I'll go V cross W. That produces a third vector that is orthogonal to both. So we'll call this X or Z. Let's go with Z. And then Z is being dotted with U. Z dot U is giving me 0, which means Z is orthogonal to U. What does that tell me about U? Where does U gotta be? Let's go back to the picture of the parallel pipette. What would happen if how could I get a volume of 0? It's not, I've got vectors. If there's vectors going, if none of the vectors are 0 vectors, I should have a volume unless one particular thing happens.
Someone said it's because they're parallel.
Not necessarily parallel, but they're all in the same plane. If this is, let me do it up here. So let's say that's U, this is V right here, and this is W. The only way I'm going to get a 0 is if W is not actually going outward. It's in the same plane. It doesn't have to be parallel. It could be. It could be parallel to W or V, or it could be parallel to U. But in general, if they're all in the same plane, we've got nothing that makes it give it depth. It's just a flat piece of paper rather than 3-dimensional.
Basically,
So
the depth of the cube is just 0.
Yes, the depth is 0. When you get the depth of 0 from the scalar triple product, depth is 0, it means they are coplanar, which means they all exist in the same plane. All right, you guys ready for the fun one? This is the fun one. I like this. This type of problem might be on the test. This is the beauty. I am so impressed by this that it's simple. Confirm a basic trig identity you already know. Doing vectors. Any ideas how we could tackle that?
Think about your definitions of dot product and cross product. I hope I'm not spoiling it. I'm still getting blank stares.
You get sine data with the cross product, also sine data with the cross.
There you go. So they're using get sine theta from the cross product and the cosine from the dot product. Good job.
For real.
Isn't that a fun problem? It tests whether or not you remember the dot product formula, the cross product formula. Can you
And
work
how
with
you
them?
and if you
This
can actually
requires you to do the norms of vectors. So finding the magnitude or length, the norm of a vector. There's a lot of vector stuff all wrapped up into this problem.
Pretty sweet.
it's just too bad he's showing it now and not putting on the test instead.
Hey,
See, Brandon's trying to throw you guys under the bus.
Well, even without me saying it, you would have shown this on a test showing it now.
I don't test you on stuff and expect you to have never seen it before and still know how to do it. I've had teachers do that and it results in catastrophic failure on every student.
Well, you wouldn't show the exact problem at
Good
later.
man, Professor Grant, good man.
Right. Wouldn't that shock the shit out of them? I just make a test made from directly from problems with the lecture notes. That would be
Mhm.
fucking hilarious.
I think my sister told me about how an online class where like the answer to every problem was literally A. It was a hard class too. She was just getting by because of that. Oh yeah, if you wanted to show that alcohol limit problem that you were talking about earlier.
Oh, yeah,
After
it's not a problem, it's an idea.
Okay.
My instructor, my graduate school instructor, his name was Nick Brummel at UC Santa Cruz. He was explaining the concept of the limit as something goes to zero. Like let's say X goes to zero. X going to zero, we are so used to saying plugging in zero and going for it from there, but it's not. X going to zero is not the same thing as X equals zero. And proof of it is take a martini. It's made with gin and vermouth. And as long as you can have a lot of vermouth or a little vermouth, even down to a drop of vermouth, it's considered a dry martini. As soon as there's no vermouth in it, zero vermouth, it's just straight gin and it's purely undrinkable. That was his proof or example of how limits don't automatically just plug in equals zero. It means something important when you're working on scales like in astrophysics and stuff, because something that's 0.000001, while is really small, may be multiplying by something that's in the trillions, and it ends up being still a big value. So don't just assume it's zero. It was a fun lesson using martinis.
Sounds like a fun feature if that had.
He told us we were stupid Americans often. He's in English. It was great. Because it made it worse when we'd say Z and he'd go, it's not Z, it's Z. and we kept saying Z, and then we had one Greek student in our cohort, basically, the students that all came in at the same time. And he said beta wrong. He said beta, like alpha and beta. He said beta, and it's not beta, it's beta. And the Greek student said, "You English people are so stupid. It's beta." And I just laughed my ass off. She was a gutsy girl. I like her. But he said it out, being fun.
I had interesting teachers in middle school. I had my 8th grade English teacher. It was the first and only Black teacher I've ever had. First of all, and second, she would always say, you're gonna be in high school like in a few months, so get your act together, And here I am, like what feels like a few months later, I'm in college. Yeah.
That's funny.
She was one of those like really wise teachers. Like she was taught like everything from kindergarten to like college level. So okay.
Fun fact for all the guys in the room or girls that like girls. If you choose a university for your university that's on a coastal town, a lot of the weather is usually perfect for swimwear. And so a lot of ladies walk around in just swim clothes. Good times. All right, so what's the smart way to go about this? What's getting used more than once? We need magnitude of U and magnitude of V in both areas. So maybe we should find those first and not do them more than once. Which is funny because it's going to be identical to V. Uh, 36 and 4 is 40 plus 9 is 49. These are all 7.
That's mighty convenient.
It
I'm
is
sure that
convenient.
wasn't planned. I'm sure that was totally unplanned and uncalculated.
So we've got U dot V. If I divide through by U and B, magnitude of U and B, it's really 7 times 7 is 49. That's my cosine theta. So U dotted with V is 2 times 2 plus 3 times 3 plus negative 6 times 6 over 49. And I get what? 4, 9, and 36 is again 49, negative 49. U cross V, I'll divide by 49 afterwards. But we've got I, J, K.
Well, they're both 7. When we square it, it makes out.
I do find it handy to write the J as negative before if you've noticed me do this, I write this every time because it makes me remember to do the negative. That's
Oh,
one of the
yeah,
easiest things to forget.
I tend to go straight to that and usually don't go try to skip any beyond that because I tend to make mistakes around that point. It's usually the basic arithmetic that gets you.
They used to call arithmetic archimedes.
Isn't that the name of a Greek guy, like famous Greek guy, like Artemius or something?
Is that really 0K? Yeah.
Yeah, that would be 0 from the looks of it.
I think I got those all right.
Then you have to find the magnitude of it.
That's what I got.
Yes, got a question?
I've got something wrong because this square is going to give me 1 already. Sign should be 0 here if that's 1.
Oh, okay.
2 times 2 plus 3 times 3.
Yeah, that should be like
negative 49, right? Then negative 23.
Yeah, they're saying it should be, you said negative 23?
Yeah.
Yeah, it should be negative 23 over 49. You said,
Where?
Negative
Up here?
over 49.
yeah,
Oh, I
yeah.
added rather than subtracted. Good call. That's what's wrong. Negative 36, minus 13. You're right. Negative 23. I knew something was wrong because this would have to be 0 and it's not 0. All right, so let's find the magnitude of this bad boy. I don't like that. How I'm doing this. Let's see. They're both divisible by 4. So I can
Well, they're
pull out
this
a
is
4
it.
squared.
Okay, I was gonna say you could pull out a 6 square, but that works too.
Oh, 6 is better. So I've got 6 times square root of 100, which is 60. $36, not 100, never mind. 36 plus 16 is 52. So I guess I could have pulled on, these are both divisible by 12. This is 4 times 13, so I can pull it out, make it a 2 when it comes out. I've
That
got
would
12
be-
root 13. That's over 49 would give me sine. So cosine squared theta plus sine squared theta, does that equal 1? All right, so let's see. 23 squared is, I got 529 plus 144 times 13. Oh yeah. That's a neat problem, isn't it? Got to be
Just,
careful in that.
Yeah, there's a lot of arithmetic to just like slip up on because of all those big numbers you use.
A different answer.
Right.
You gotta
Any questions from anybody?
I just proved this.
We'll check for any arithmetic mistakes because you're dealing with a lot of big numbers. So oh, let me rephrase that. Check for any Artemis mistakes.
Well, you know it's got to equal 1 because this is a basic trig identity. It's got to equal 1. So if you don't get 1, there's a good chance you made a mistake somewhere.
I got 1.119.
Well, unless you just proved like one of the most basic trig identities, probably you should check your work. All right.
That's pretty cool though.
Other than arithmetic mistakes, any questions? I think we're good.
That's pretty neat. Any arithmetic mistakes, like this one last though. The dot product, I got the slot product, I was like,
Okay, I think we're good on this end. What about Zoom? Are they doing okay?
They have not sent any chat message, so I think everyone's doing okay. How's my
Then,
Zoom
like,
peeps?
Yeah.
All right, I'm gonna go ahead and. All right,
9/11 every single day.
tomorrow I'm gonna have my SI from 8:30 to 9:30 and Yokta 13, and I'll have my SI from 12 to 2 and current 712B. So if you ever need any.
This is like 3 different rooms.
Shit, don't blame me. Blame the school for moving me. Don't worry, I'll post an announcement tomorrow.
You can blame Brandon for part of it. He chose deliberately to keep Yocut 13 when he moved.
Okay,
other stuff.
okay. I'm sorry if I like Yocut 13.
So he can be blamed. Don't let him lie to you. If you guys want Starbucks, I've already got Sunday confirmed from 8 a.m. to 10 a.m. If anyone wants me to be at Starbucks on Saturday from 8 a.m. to 10 a.m., someone's got to message me, email me, Discord me, text me, come over to the camera and say so. Otherwise, I'm sleeping in on Saturday. I'll make an announcement about this too.
Sounds good. Have a good weekend, Professor Jones.
You too. Have a good weekend. Caldwell and Demery.
Yeah.
Oh, let me ask him. Hey, Mr. Jones.
Yeah.
How there, we got someone wondering how you, they can get in contact with you to, how to text you to, that they want to do Starbucks.
They can walk over to the camera right now and tell me.
Okay, I plan to go to the, oh my God, the camera's so low. I
Oh, all
plan to
right.
go to the Sunday one.
Cool.
I'll be there on Sunday too.
Sunday, was it Sunday for both of you?
Yeah.
Yes,
Okay, so no Saturday confirmations yet.
Yeah, Professor, I'll be there, stop by, but well, if I didn't finish my essay on Sunday, I'll probably go back home and still writing.
Okay,
Friday, lucky you.
so is anybody coming Saturday at this point?
I'll go to SI on Friday.
That's not what I was saying.
Are you going for sure? I think
What?
two of them just went there. They gonna go.
On Saturday? Okay,
You going there for sure, right, buddy?
On Sunday.
Uh-huh,
Yeah.
you do?
So I'm doing something on Saturday. I'm gonna go to the Saturday one.
Okay. He's saying he gonna go on Sunday. I'll
Sunday,
stop by
okay.
there.
Okay.
Start at 8, right?
What?
8 o'clock.
Yeah, 8 a.m.
All right.
I'll be there.
Oh, Mr. Jones.
Yeah,
I got an email this morning from McGraw Hill apparently confirming whether because apparently I'm guessing it was just maybe a mistake or spam or whatever, but I just wanted to clear it with you. McGraw Hill, I don't know, you know what McGraw Hill is, right?
yeah, it's a textbook publisher.
Yeah. They emailed me saying that I sent in a request to be an instructor. So I wanted to clear that with you to make sure there wasn't any mistake on your end.
I didn't send anything. I don't know what happened.
Okay, then I'll go ahead and ask Mrs. McPherson because we had a problem where when I signed up for Alex, because I was an SI, they cleared me as an instructor instead.
Oh, okay.
Yeah, so I just wanted to make sure there was nothing on this end.
Okay, no, yeah, I haven't done anything.
See you later.
All right, see ya. We'll see everyone later then. If the Zoom
Yeah.
users have no questions, we can call this a wrap. You're welcome. You're welcome also. All right, we'll close it out.